Hey guys, Mr. Backerberg here. In this video, we're going to look at common logarithms in base 10.
Because of their connection to our base 10 number system, the metric system, and scientific notation, logarithms with base 10s are pretty useful, and we call those common logarithms. As we're writing out a base 10 logarithm or a common logarithm, so a base 10 would be log base 10 of some number. We don't typically put the base 10 on there, so this log base 10 of x, we would usually just see it written as log of x, and that's an implied base 10. Now when we're dealing with common logarithms or base 10 logarithms, they have the same basic properties that other logarithms have. So if we were looking at log of 1, that's going to equal 0, because if we think about that base of 10 being raised to the 0 power, that's going to equal 1. Or if we were going to look at log of 10, this is going to equal 1. There's an implied base 10 down here, so 10 to the first power is going to equal 10. So similar properties to what we've seen before with logarithms. Or if we had log base 10 of y, that's going to equal y because this is a base 10 logarithm, so this logarithm and this base 10 exponential are going to cancel each other out. Or if we had 10 being raised to the log of x power, then that's going to equal x because this exponential base 10 would cancel out with this logarithm base 10 and we would just have that x left over. So let's look at a few examples. Let's say we wanted to do the log of 100. So this is a base 10 logarithm, so we would want to be thinking to ourselves, what power can we put on 10 to get 100 as our answer? And that power is 2, because 10 squared is 100. Now let's say we wanted to look at the log of the fifth root of 10. Now I'm actually going to look at rewriting that fifth root. We can rewrite that as log of 10 to the 1/5 power, and because this is a base 10 logarithm, then that's going to cancel out with that base 10 exponential, and all we're going to have left over is the 1/5 power. In this example, let's look at log of 1 over 1,000. And again, this is a base 10 logarithm, so I want to see if I can take this 1 over 1,000 and rewrite it as a 10. Well, 1,000 is 10 to the third power, so we can think about this as being 1 over 10 to the third power, but then I can take that 1 over 10 to the third power, and I can rewrite that as 10 to the negative third power. So this base 10 logarithm and this base 10 exponential are going to cancel each other out, and all we're going to have left over is that negative 3 power. And for our last example in this set, we want to look at 10 to the log of 6 power. So again, we have to remember there's no base written down here, so that's an implied base 10 logarithm. So that's going to cancel out with this base 10 exponential, and all we're going to have left over in here is that 6. Now, not every logarithm can be calculated by hand, so we're going to use our calculator to help us out a little bit. There is a log button on our calculator, so we're going to look at some that are not very solvable by hand. So like the log of 34.5. If we tried to figure this out by hand, we'd be thinking, what power do we need to put on 10 to get 34.5 as an answer? And that's just not easy to evaluate. So I'm going to use my calculator to help me. So on the left-hand side of my calculator, I'm going to find that log button. I'm going to type in 34.5, close up my parentheses, and hit enter. And I get 1.538 approximately. Now if we wanted to look at the log of 0.43, we would have to be thinking to ourselves, what power do we have to put on 10 to get 0.43 as our answer? And again, I'm going to use my calculator to help me out. And if we find our log button on the left-hand side and go 0.43, close up the parentheses, and hit enter, we'll get approximately negative 0.367 if we round that off. And we can also try to look at log of negative 3. So we're trying to think to ourselves, what power do we have to put on 10 to get negative 3 as an answer? And again, I'm going to use my calculator to help me out here. So if we go log of negative 3, close up the parentheses and hit enter, we can see that we get a non-real answer. We cannot evaluate logarithms of negative numbers. There is no power that we can put on 10 to try to get negative 3 as an answer.
Now we're also going to get into solving some simple logarithmic equations. So let's say we wanted to look at the equation log of x equals 3, and we're trying to figure out what this x value is. Well, we're going to think about this using its exponential form. There is no base written on this logarithm, so it's an implied base 10. So we would take that base of 10 and we would make it the base of an exponential function. The answer goes up as the power, and the number that you're evaluating becomes the new answer to this exponential function. So 10 to the third power is equal to x, but 10 to the third power is 1,000, so that x value is 1,000. Or if I wanted to look at log base 2 of x equals 5. Here we can see that we've got a base of 2, so I would take that base of 2, I would take that answer of 5 and put it up as an exponent on that 2, and it's going to equal this x that we're evaluating. Well, 2 to the 5th power is 32, so that x value is 32. That's going to be it for this video. Thanks for watching.